Okay, we're going to go through the practice quiz. I'll just kind of go through each step and try to pause a little bit, so if you need to stop and think about what I said before you move on, that would be fine. So after each step, I'll just kind of pause a second. So first step is always to factor. So with this one, I would factor this into x times x minus 4. Don't forget to look for that common factor. That's the first thing you should always look for. And sometimes people miss that step and then they can't factor it. So it does factor by taking out an x. You have two separate factors. So I'm just going to write this then in my partial fractions. I'm going to write that as a over x and b over x minus 4. Both of those are just simple linear factors. All right, so that equals 6 over this. So what do I need to do? I need to look at these two and say, okay, remember, focus on the denominators. If I have this denominator, what do I need to multiply it by to get an x and an x minus 4? That's my least common denominator. So instead of worrying about cross multiplying, you want to think about, this is the denominator I have, this is the denominator I'm trying to get to. So I already have the x, so I need to multiply by x minus 4 over itself. So when I do that and distribute the a, I'm going to get ax minus 4a. For the second fraction, I have the x minus 4, so I need to multiply by x over x, so that I get x minus 4 times x on the bottom. I get bx in the numerator. All right, all of that, remember, equals 6 over x times x minus 4. So now that I see that these fractions are equal, the numerators are what we're going to focus on. They have to be equal to each other. So I know that when I take ax minus 4a plus bx, that has to equal 6. So what's my system of equations going to be? It's going to be a plus b. When I look at the x's, they have to add up to how many x's I have on this side, which is 0. When I look at the numbers, negative 4a is the only thing I have over here. That has to equal the number over here, which is 6. So this is a pretty simple system of equations. The x's, a plus b, have to add up to 0, and the number, negative 4a, has to add up to 6. So here I can solve for a by dividing by negative 4. I get a is negative 3/2. I have to plug that back into this equation to figure out what b is. So negative 3/2 plus b has to equal 0. So b is going to have to equal positive 3/2. So when I go to set this up now, I know a and I know b. So to write the equation, the final answer, I go back to where I started from. A was over x. So I need to write this as negative 3/2 over x. Plus, the b was over the x minus 4, so positive 3/2 over the x minus 4. Now you're not done because you have this complex fraction. So the first fraction you'll multiply by 2 over 2 to get rid of that 2. The second fraction has a 2, so I'll have to multiply by 2 over 2. So when I do that, I get negative 3 over 2x. Plus, here the 2 cancels, I'm left with 3 over, I can either write it as 2 times x minus 4, or you can distribute that 2 and say it's 2x minus 8. Okay, that's your final answer. All right, number 2. 2, I have 4 terms in the denominator, so I have to factor by grouping. I'll group the first 2 together, take out an x squared. Take the second 2, I'll take out a 9. And so when I factor the denominator, I'm going to get x plus 1, that's my common factor, and then x squared plus 9 is what's left. Now, if that would have been x squared minus 9, I could have factored that as the difference of squares and had 3 different factors. This, though, cannot be factored any further. So that means when I go to set this up, I have to use that case 3 that says if you have a factor that's a quadratic, we have to put a linear on top of it. So this one's a linear, so I'm okay to write a over x plus 1. But then for the second one, when I have the denominator of x squared plus 9, that's the second one here, I have to write this as a linear bx plus c. So factoring this after you get it factored by grouping, it's factored completely, so it's going to be a over this term, but then it has to be a linear over that denominator, bx plus c. All right, so now again, focus on the denominators. I want to get a denominator that has an x plus 1 and an x squared plus 9 in both of those fractions. So the first one has the x plus 1. So I need to multiply by x squared plus 9. So I get ax squared plus 9a. Second fraction has the x squared plus 9, so I need to multiply by x plus 1. Now I'm going to have to do some foiling because I have a binomial bx plus c times another binomial. So I'm going to FOIL. I'm going to get bx squared plus bx, and then I'm going to get cx plus c. And all of that equals this fraction that we started with that just has an x in the numerator. All right, so setting up our system, we look at the x squareds. I have an ax squared plus a bx squared, so a plus b has to equal no x squareds over here. I look at the x's. B plus c has to equal the x's over here, which is 1. And for the numbers, I have a 9a plus a c has to equal a 0. There's nothing over on that side. So there's my system of equations. You notice that it's kind of different combinations. I don't have a c in this one, I don't have an a in that one, I don't have a b in this one. So sometimes those might be easier to use substitution. Like you could take this equation and solve it for b and substitute in here. Take the bottom equation, solve it for c, and substitute it in there. So you definitely could use substitution on this one. I'm going to stick to elimination because that's the way we've usually been doing it. So when you have 3 variables, you have to pick a letter to eliminate. So I'm going to pick the c's to eliminate. So this one already has an equation where the c's are eliminated. I just have to take these 2 equations and eliminate the c. So I'm going to multiply the middle equation by -1. And I'll write it down here. I'm going to get negative b minus c equals -1. And so now I see that, yep, the c's will be eliminated. I'm going to have 9a minus b equals -1. There's a second equation where I've eliminated the c. So the first one already was eliminated. That's what I picked that one. So then I decided if I wanted to eliminate the c's, I had to use those 2 and eliminate the c's. Now you're down to a system of 2 equations, 2 variables. And sometimes it is helpful to start, boxing in those equations that you're going to work with, so that now it's easy to see that, okay, yeah, I'm down to 2 equations with the variables a and b, and I look at these right away and see that, oh, I already have the b's that are opposite, so I can just add those together as is. A plus b equals 0, and 9a minus b equals -1, and I get 10a equals -1. So a is going to equal -1/10, which is kind of an ugly number, but it's doable. So that's a. I have to find b and c. So let's plug a back in right there, the first equation. -1/10 plus b has to equal 0. So b is going to equal +1/10. And then to find c, maybe we can work with this equation. B plus c has to equal 1. So 1/10 plus c has to equal 1. If I subtract 1/10, c would be 9/10. So those are my answers for a, b, and c. Now we need to plug them back into our original. So remember what those are. We're going to take a as -1/10. A was the number that was above my x plus 1. So I'm going to have -1/10 sorry about that, negative 1/10 over x plus 1. And we'll have to take care of that complex fraction in a second. B was 1/10, so it's plus 1/10 x plus c, which was 9/10, all over x squared plus 9. Okay, so that's what I get using my a, b, and c, but we have to get rid of the complex fraction. So if this has a 10, I need to multiply that by 10. So 10 times negative 1/10 is negative 1 over, you don't have to distribute that 10, you can leave it like that. If you do, that's fine as well. Here I need to multiply by 10 over 10. So when I do that up here, I'm going to get 1x plus 9. And down here, I'm going to leave it as 10 times x squared plus 9. You can, again, distribute that to get 10x plus 90 if you would like. But there's the answer to that one. So that's the front page. You know, and you don't have to worry about which case you use, but basically this, if you're kind of thinking about it, this came from case 1 when we first got started. You just factor the denominator, and it's just breaking up those fractions and then using your method to get the same denominator so that then you can use your system. And on this one, because you had that double, or you had that quadratic factor, you had to use case 3, which said if this is a quadratic, then you have to have a linear above that one when you break it up. And then again, you do the same process. So that's kind of the cases. That's why we set it up the way we did. So make sure you understand that those cases as you go through.